All right, y'all. Next, we're going to talk about our ellipses. That's the next conic section. Ellipses. Let's start off with a definition. Definition is, you might want to take a moment and press pause to copy this down. But ellipses are the set of all points where for each point, the sum of its distances, d1 and d2, from two fixed points, f1 and f2, is constant. f1 and f2 are each called a focus. Go ahead and press pause and write that down, and then we'll talk about exactly what all that nonsense means. Okay, so before we talk about what that nonsense means, let's talk about the general form. The general equation of an ellipse. General equation of an ellipse is this. It's going to be parentheses x minus h divided by r sub x quantity squared plus y minus k divided by r sub y quantity squared equals 1. Now, that looks pretty scary and everything else, but let's look at what's going on here. We got the center. The center is the point HK. And then we got R sub X and R sub Y. R sub X is the units from the center moving left and right. Oh my goodness, that's the worst arrow. Units from the center left and right. I'll actually call it the x radius. And y is the units from the center moving up or down, or the y radius. All right, let's take a moment here. So here's what's up. Let's suppose that I have a ellipse that's centered about the origin. This is the center. The x radius, r sub x, this thing here, r sub x is going to take us left and right. Whatever the radius is, it's going to take us the same amount, despite what it looks like there. Yikes. Left and right, the same amount left and right. That's our x and y radius. Or excuse me, our x radius. Our r sub y, or r sub y radius, takes us up and down however much. So r sub x tells us left and right, r sub y tells us up and down, and then that's going to make our ellipse. Our ellipse is going to look something like this. It's like an oblong circle, like when I tried to draw a circle by hand yesterday, right? Anyways, all right, so again, this is r sub x right here. This is r sub y. Now, some point along the way, we're going to find out about 2 points here called f1, and there's another point here. Let me get rid of this r sub x. Oh my goodness, this is not going like I hoped. And another point right here called f2. These are called foci. And what the definition was saying was that any points on the ellipse, for example, this point right here, the distance from to f1 plus the distance to f2 is always the same no matter what point you pick. For example, if we picked this point instead, the distance from f1 and f2, this plus this, is going to be the same as the green sum. All right, that's not terribly important, but that's what an ellipse is doing here. All right, so more definitions. Let's talk about the major axes. The major axis is the longer axis. Thus, the minor axis is You guessed it, the shorter axes. So in this picture up here, judging by this picture, the x length is this is the major axis here. The y is the minor axis because it's shorter than what the x one is. Now, that brings us to the semi-major axes and the semi-minor axes. All right, both of these are 1/2 either axis. All right, so whichever one is the major, it's half of that is the semi-major. Whichever one is the minor, half of that is the semi-minor. All right, now again, in this case the semi-major, the major in this picture looks like it's the x one, so the semi-major is half of that, or it's what r sub x is. And in this case, it's r sub y. But again, these can switch depending on each problem. All right, now, that's kind of a weird word. We'll get into more about that, why that's important in just a minute. But that brings us to our focal radius. This is going to be important here. Our focal radius is called C. Now, I don't know why they called it C, but C squared equals the semi-major axes, quantity squared, minus the length of the semi-minor axes, quantity squared. All right, and once you plug in these things, you solve for C. C is the distance from center to foci. C is the center, or is the distance from the center to the foci, or again, that's called the focal radius. Now, another thing to note is this: the foci. There's always going to be two for ellipses. The foci are always on the major axes. Foci are always on the major axes. Smith, you just talked for 10 minutes and I don't know what you just said. All right, we're going to do one example and then we'll do a ton more in class. Our first example is going to be 49x squared plus 9y squared minus 196x plus 72y minus 101 equals 0. All right, so just like circles yesterday, we're going to get rid of the constant, separate our x's and y's, and then complete the square. All right, so in this case, we got 49x squared minus 196x, leave a space, plus 9y squared plus 72y, leave a space, equals 101. Now, this one's a little bit more difficult because there's a leading coefficient. We have to factor that off. So I'm going to factor out the 49 on just the x's. So 49 times quantity of x squared minus 196 divided by 49 is 4x, leave a space. Then move on to the y's. The 9's got to factor off, so 9 times quantity of y squared plus 8y, leave a space, equals 101. So now, complete the square both times. Half of b here is -2, so that's we're going to add 4 here. But what am I going to add to the right side? I got to actually multiply that 4 times 49, so I'm actually going to add 196 to this side. And on this side, half of b is 4, so I'm going to add 16. But when I distribute the 9, I'm actually adding 144. All right, so now we factor. We factor to, 49 x minus 2 quantity squared plus 9 times the quantity of y plus 4 quantity squared equals, add this mess up, I believe you come up with 441. Alright, I'll give you a second to catch your breath, and while you're catching your breath, remember that the general form for an ellipse is x minus h divided by r sub x quantity squared plus y minus k divided by r sub y quantity squared equals 1. Well, right now, I got a whole bunch of mess equal to 441. I want it equal to 1. So there's two ways to do that. I could subtract 440, but that's not what we're going to do here. Instead, we're going to divide by 441. But here's the trick. You got to divide all three of these things, both things on this side and the entire left side, by right side rather, by 441. We're going to divide lottie-dottie everybody by 441. Now, 49 41 reduces to x minus 2 quantity squared over 9. Get out your calculator, do 449 divided by 441, and then math bracket. Plus 9 441ths is y plus 4 quantity squared divided by 49 equals 1. All right, so this is starting to look a little bit more manageable. But look at this. See how r sub x, the denominator here, is tucked inside the parentheses? We need to do that too. So what's going to happen here is that, what would I have to do to the 9 to get it so that when it's squared, whatever's inside here, if I squared it, would come out to be 9. We're going to take the square root of this, and we're going to have x minus 2 divided by 3 plus y plus 4 divided by, what's going to happen here? 7 quantity squared is equal to 1. All right, so that's our graphing form. We took this mess and made it into a new mess. Let's talk about this new mess. First of all, where's the center? The center is at the point 2, negative 4. What about r sub x? R sub x is 3, and r sub y is 7. All right, so let's start there. Let's graph this. Oh, I'm just going to make a sketch today for this one problem. Our center's at 2, negative 4. So I'm going to make a bunch of tick marks. Sorry, guys. I can't do it. You guys keep making your tick marks, or if you've got a grid, insert your grid. Oh my goodness. Sorry, y'all. Alright, let's do this. So, our center is at the point 2, negative 4. Now, our x radius is 3, which means that from our center, we're going to go 3 in the x direction. 3 this way, and 3 this way. Our y radius is 7, which means we're going to go up 7. 1, 2, 3, 4, 5, 6, 7. And down 7. Oh, I'm off the grid a little bit. And draw your ellipse. That's it. We just drew our first ellipse. Alright? But there's some other things that I want to know about. I want to find, the other things I'm going to expect you to graph are the foci. And that brings us here. The foci. Now, if you recall from the first page, c squared equals the semi-circle major squared minus the semi-minor squared. Now remember, semi-major and semi-minor are r sub x and r sub y. It's just a question of which one's major and which one's minor. So in this case, we're going to do c squared equals semi-major. The major is going to be 7 squared minus the minor here is 3 squared. So you got c squared equals 49 minus 9 is 40. Square root both sides, and you get c is plus or minus. I want an approximate here. So go ahead and bust out your calculator, do the square root of 40, and you'll get approximately 6.32. 6.32. Now, this is the distance that the foci are from the center. So remember, we're using this center, but the foci are 6.32 units away from it on the major axis, which means that our y is our major axis. So we're going to go 6.32 units up from the center. 2, 3, 4, 5, 6, and then a little bit more. So right there is F1. Now what are the coordinates of that? Now since we went up, the x coordinate didn't change, right? F1 is the coordinate 2, comma, and we're adding 6.32 to negative 4. So it's going to be 2.32. And then f sub 2, the x coordinate does not change, but it's going to go down 6.32 units. So this is f2, and that's going to be negative 10.32. All right, we did negative 4 minus 6.32, and that's where the coordinates of f sub 2 came from. We're going to do a bunch more of these. Smith out!